Defoliation of soybeans by insects and mites causes serious concern every year throughout the state. There is a significant difference between full season versus double crop soybeans relative to which pests attack them, when they attack, and the effect they have. Full season soybeans may be susceptible to wireworms and wire grubs early in the season, but double crop soybeans are not as likely to be attacked. Both may be defoliated by adult beanleaf beetles, webworms, mites, green cloverworms, and woolly bear and thistle caterpillars, but usually not to the extent that requires treatment. Some of the perennial pests in soybeans across the state include wireworms and white grubs, pillbugs, beanleaf beetles, soybean podworms, green cloverworms, thistle caterpillars, stink bugs, soybean aphids, and Dectes stem borer. Beanleaf beetles have historically been a serious pest of soybeans throughout all soybean-producing regions. Adults can affect early season plants by chewing round and or oval holes in leaves. Females then oviposit in the soil around the base of the plants, where the white larvae feed on roots and nodules. Emerging adults feed on leaves, but also may feed on green pods, which can cause yield loss relatively quickly. Foliar insecticide applications usually work well to control beanleaf beetle adults and prevent this kind of pod feeding. Most of the damage caused by beanleaf beetle on pods is cosmetic. The real issue is when adults feed on the connecting point of the pod to the stem. A more important pod feeder is soybean podworm, also called corn earworm and corn. Adults fly from corn to soybean, where females oviposit on leaves, and newly hatched larvae often feed on the beans through the pod. Adult beanleaf beetles feed on the pods, whereas podworms chew through the pods to feed on the seeds within. Early detection, while the larvae are still small, is key to good control. Ensure proper identification of larvae, as other worms commonly found in soybeans do not feed on seeds. Small, hair-like microspines on podworms are the key to identification. The beanleaf beetle is red to light tan, 1/4 of an inch long, and found in all parts of the state. The upper back is marked by 6 black spots near the midline, bordered by a narrow black band. Insects react to nearby disturbances by dropping to the ground. Typically, beanleaf beetles chew oval holes in the foliage, causing damage of little economic consequence. Border rows of emergent soybeans may support populations capable of causing localized economic loss. Treatment in limited areas may be justified in the case of severe cotyledon feeding, threatened destruction of the growing point, or populations of 7 beetles per row foot on soybeans with 4 or fewer nodes and 25% defoliation. Most years, 50 or more beetles per row foot are required to reduce yields in late season. Treatments may be justified if significant pod feeding occurs while pods are still developing. This pest is also known to transmit bean pod mottle virus disease. Research is ongoing to determine if reducing the treatment threshold would reduce the chance of plants being affected by this disease. Several seed treatments are labeled for early season protection against beanleaf beetle. A seed treatment is not justified solely for control of beanleaf beetle unless there have been recurring problems. Neonicotinoid insecticides are highly water-soluble, and plants can absorb them and move them through their circulatory system from the root zone up into the leaves and other tissues. These neonics are widely used across the north-central region to prevent early season damage caused by insects like beanleaf beetle. Although effective when populations are high, neonicotinoid seed treatments offer soybean plants a narrow window of protection, a maximum of 3 weeks after planting. As such, they can be useful for managing early season pests in targeted high-risk situations. Examples of such high-risk situations include fields transitioning to soybean production from pasture, conservation reserve program land, or grassland to soybean production, or second crop or specialty crop soybean, in other words, double crop or food grade or seed soybean. It is important to keep in mind that these high-risk scenarios are uncommon in northern states. Seed and seedling pests such as wireworms, white grubs, and seed core maggots rarely reach economically damaging levels in the vast majority of soybean fields. Although adult beanleaf beetles are frequently encountered in newly emerged soybean, they rarely cause more than cosmetic injury to plants and require at least 7 adults per row foot in early development and up to 50 per row foot in later season soybean. As awful as this ragging looks, it is important to keep in mind that soybeans are actually quite resilient and can tolerate considerable early season damage without suffering economic losses. Also keep in mind that neonicotinoid seed treatments pose risks to non-target organisms in two main ways: off-target movement and environmental persistence. In target pest populations, neonicotinoid seed treatments pose the threat of resistance development as well. These insecticides are highly soluble in water, but also persist in the environment. Neonicotinoid residues from seed treatments may be found in the soil for months or even years after planting. Neonicotinoids can also make other organisms toxic. This phenomenon was documented in slugs, which are not sensitive to neonicotinoids, but ingest them when they feed on plants grown from seed that's treated with this pesticide. Most insect pests of soybean have well-established scouting guidelines and thresholds. Specific recommendations are available from University Extension Service websites and publications. When pest problems occur, the best management is based on an integrated approach that can include rotating crops, conserving natural enemies, using soybean varieties with resistance to pests, and scouting and applying insecticides at established thresholds. Scouting and selectively using any insecticide offers the long-term benefit of extending the useful lifespan of that product. Selective use also reduces short-term production costs. Too often, growers frequently face limited choices regarding seed treatments. Growers who desire untreated soybean seed or seed treated with only fungicides should let their seed dealers know as early as possible when ordering seed for the next growing season.